bingo, what's his name?
And you weigh the right things on the right side and the wrong things on the wrong side.
Cosine equals 87 divided by 105, the square root of 105.
I mean, I can't always be their little girl.
Middle childhood. It's a time to learn. A time when our understanding of the world takes shape. A time when we become able to deal with complex thinking tasks, like understanding abstract ideas.
The blindfold mainly symbolizes that the judge should look only at the evidence and the law and not at the features of the accused person.
And the mysteries of mathematics.
Turn them into a fraction. You do 4/7.
Thoughts that in the preschool years would have been incomprehensible.
Well, it's sort of hard because half of you is saying that, no, you shouldn't give them the money, and half of you is saying that, you know, because it's your friend and stuff, so you should, and it's pretty hard to make the decision.
What is the nature of these fundamental changes in our intellectual abilities? Pioneer developmental psychologist Jean Piaget was one of the first scientists to systematically note the dramatic changes that occur in children's thinking. Piaget outlined progressive stages of development. The middle childhood years, from about ages 6 to 12, he described as the concrete or logical operational period.
And for Piaget, this meant that children were able to solve in a very concrete way problems that were posed to them by their environment, problems relating to quantity, mathematics, logic, space. We now see this great step forward towards objectivity. In other words, a child can, in the task of the liquids, conservation of liquids, conserve the amount of liquid through physical transformations. Is there the same amount in both?
Yeah, I think so.
You sure?
Mm-hmm.
Very good. Now watch, I'm going to take one of these beakers and I'm going to pour it in here. See, now this is a major step forward in terms of thinking. The child is able to conceptualize an amount and realize that the amount does not change because the shape, the physical shape of containers that this amount of liquid may be in necessarily changes.
Same in there.
The same. And how do you know that?
Because if it was in here, and like you poured it in, but there were still little drops left, but you said to just pretend you put it all in.
Right.
How could it change?
Very good.
During middle childhood, we see dramatic improvements in children's ability to manipulate information. Prior to 7, Piaget thought children were unable to solve conservation tasks and a variety of other tasks. What we've discovered with more recent research is that younger children can solve those tasks than Piaget thought.
Yeah. Does this glass have more water? Does this glass have more water? Or do they both have the same amount of water?
They both have the same amount of water.
The part of it that Piaget seems to be correct about is that earlier than age 7, those skills are not used very effectively in trying to acquire knowledge about the world. And after age 7, they become quite useful skills for investigating the world.
4 times 1 is 4. 4 times...
By the time we get to age 10 or so, we see children beginning to detect patterns in the memory information they're encoding. So they begin to see the pattern that when they're doing their times 9, the unit digit keeps decreasing by 1 each time you go to the next higher multiple. That's the kind of pattern that you would not see a 2nd or 3rd grader detecting because they're still down there working at the rote memory level. Once that part of the process becomes well enough practiced, it gives the child flexibility to begin to detect other kinds of patterns.
It's a well-known phenomenon amongst schools that The learning of fractions is a watershed, for example. When children come to learning fractions, some just simply find this extremely difficult. It continues to be a problem for them. The difficulties with fractions is recognized in these pre-algebra classes that children will take in the hope that a little further instruction will maybe get them ready to take algebra. Why? What's so hard about a fraction? Well, there are two ways of thinking about fractions, and we do. One is to think about them in terms of pieces of space cut up. You share a pie into so many pieces. There's another way of thinking about them, and that's to think about them in terms of two cardinal numbers divided by each other. As soon as you make that move, you're making a mathematically rich move. You're making a formal move.
4/4 equals 1 whole. Have we plowed the whole field, Brent? We have. No. How much of the field have we plowed? Esther?
3/4.
3/4 of that field has been plowed. How many of you agree with Esther? All right, she's right on. She's got
Cardinal
the right answer.
numbers divided by each other, well, these things aren't what you get from counting. These are conceptual understandings that depend on understanding the structure that carries with it things like division, multiplication, and the like. The language of mathematics is not the same as the language of English. Multiply, for example, in English always means increase. That is not true in mathematics. If you multiply two fractions, you do not get a bigger number, and yet many children through high school believe that must be the case. So you've got this clash, if you like, of the natural language with the formal language.
Recognizing groups is a thinking skill even infants can do to some extent. Toddlers and preschool-age children can differentiate even larger numbers of categories and classes. And even more complex skills of classification develop in middle childhood.
The intersection of classes experiment measures whether the child is able to grasp an intersection of two different logical categories, here, color, and shape. Can you imagine what kind of piece do we need to put in here?
A triangle.
A triangle? And what color triangle?
A blue.
A blue. And explain to me why you have to put a blue triangle in there.
Because these are the same, so this should be the same. But it doesn't have to be.
20 questions task attempts to assess how the child develops efficient logical strategies for eliminating objects when you have to guess one in a series of many, many objects. You've got to ask me the kind of question where I say yes or no. That's all, okay? I can only answer with yes or no. Okay, so I've thought of something, and now you can ask me the questions. Think of different ways you can ask me.
Is it in the top row?
No.
The 5th from the top?
The 5th from the top.
Right there?
Yes, it's in the 5th from the top.
Is it there?
No.
Is it that?
No. No. Yes, very good.
Memory skills are another area of cognitive development that increase in variety and effectiveness during middle childhood.
We've been studying the kinds of memory strategies children use because we think it's very important in terms of their success in learning and memory situations. We also now know that using a memory strategy is just not enough. Children need to be able to remember to use the memory strategy. That is, they need to think of using the memory strategy. And thinking of using the memory strategy is something that we call meta-memory. Something else that becomes very important is what the child knows. And we generally refer to that as the child's knowledge base or the child's world knowledge. A memory strategy that's very effective in learning pairs of words is elaboration. Elaboration consists of the child creating a semantic episode, basically a story that connects the two words. Fire, camera.
The camera is near the fire.
During middle childhood, children are beginning to spontaneously use this elaboration memory strategy. But frequently, they find the use of the strategy to be very, very effortful. In our research, we've been studying how effortful it is for children of different ages to use an elaboration memory strategy.
The cowboy lived at the ranch.
We've been doing this by asking the children to make up sentences for pairs of words, and on some trials, or sometimes, we ask the child to engage in a secondary task. The secondary task is finger tapping, and we ask them to tap as quickly as they can.
Start tapping. Fish, seaweed.
The fish thought the seaweed was another fish.
Good.
We measure how much effort, how much mental effort or thinking effort is involved by how much interference or how much finger tapping slows down when we ask them to tap and to also memorize and to use the elaboration strategy.
And then sat on her knees.
Athlete, toothbrush.
The athlete brushed with his toothbrush.
Okay, good.
We've done 2 or 3 studies. These are developmental studies where we might compare 3rd grade children to 7th grade children. And we find that it is much more effortful for the younger children to use the elaboration memory strategy.
Start tapping. Bike, skyscraper.
The greater effort that we observe in the younger age children can be observed in a marked slowdown in their finger tapping rate when compared to when the child is simply tapping alone. It can also be observed when the child's tapping is interrupted. The tapping becomes more sporadic and less consistent.
The visitor rang the doorbell.
Okay, good.
We don't have good memories. That's why we write things down. And I think that one of the exciting things that we see during middle childhood and adolescence is the child's recognition that their memory isn't infallible, and they do have to utilize memory strategies. They do have to rely on other techniques to help them improve their memory and help them remember what's really important.
So, in middle childhood, cognitive abilities strengthen and become effective tools for further learning and development.
We see that flexibility in skills with respect to classification systems, with respect to measurement systems, with respect to skills for facilitating memory. All of those skills become ones that the children use relatively automatically, which frees their cognitive resources to focus on other aspects of situations and problems.
Probably hit all zigzaggy like blah, 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 blah.
Even though a child's intellectual development may follow a predictable course, clearly the mind of every child is different. One child is better in math. The other can write well. Some are quick to learn. Others seem slow.
Good job. And now whose turn is it?
The traditional and somewhat controversial view of intelligence is that children have innate mental abilities that can be reliably measured.
One of the obvious observations that everyone makes in life is that people differ markedly in the kinds of things they can do with their minds. There are obvious differences among people, and it's of interest to psychologists to try to understand the nature of those differences, to describe them accurately, to be able to measure them, and to understand the causes of these differences. Now, the way this is studied, the simplest way, is to compare identical twins who have the same genes and who have been separated at birth and reared in different environments. Any degree of similarity between these twins now, since they're in different environments, has to be due to the fact that they have the same genes. If you get a set of twins, a large number of these twins, and separate them and rear them apart, one can look at the degree to which these twins are correlated with one another. When they're paired up, how much alike are they? And the degree of correlation is found to be quite high.
There is a lot of evidence that there is some hereditary component to intelligence. What I'm most interested in is a person's ability through environmental means to capitalize on that ability. So we find in our research, for example, that you can teach people to perform much better on the kinds of test items you'd find on an IQ test And we don't need to get into arguments about is it hereditary or is it environmental, because we know that these things can be taught, they can be developed.
We used to think of intelligence as a unitary idea, a concept that one was born with a certain potential level of intelligence based on heredity they carried with them throughout life. Now we know that intelligence is not a single entity, but one of many facets, and there are many different kinds of intelligence that people have to varying degrees and that develop as they mature throughout their lifespan.
I don't think that intelligence is a useful concept for scientific research, nor do I think it's useful in education. And I think that we should just abolish it from our vocabulary. That the important thing is to identify children who are having difficulty learning and helping them to learn without having to label them with some type of a diagnostic pseudo-medical label.
I think a mistake we make today is to say someone is intelligent if all their scores on the IQ tests or the achievement tests or whatever are at the top. But if you look at people who succeed in their everyday lives, they're not good at everything. Rather, they've found something they do well, whether it's research or being a reporter or whatever it is. They find something they do very well, and they make the most of that.
Intelligence testing began in France around 1905. The French Ministry of Education asked pioneer psychologist Alfred Binet to devise a test to measure meaning, vocabulary, and perceptual discrimination.
Intelligence tests really served a very good purpose when they were first invented. The idea was to distinguish between kids who were mentally retarded and those who were behavior problems. Because in turn of the century France, some teachers were putting kids in classes for the mentally retarded, not because they were mentally retarded, but because they didn't want them in their classes.
Binet was very clear at that time that his test should not be interpreted as measuring biological potential or the efficiency of the brain. But unfortunately, he did name his test a test of intelligence, and he did call his scores tests of mental age. And when the test then was brought to the United States by Professor Terman, who was teaching at Stanford, and Dr. Goddard, who was the superintendent of a school for the feeble-minded in New Jersey, the intent of the testing was changed. And they came to see the scores as measures of a quantity that existed in individuals, as a characteristic of people, their intelligence.
In 1950s America, the intelligence test became an instrument for classifying and segregating children according to what was believed to be natural ability.
Useful measurements of intelligence have taken two major forms: group and individual testing.
Johnny, what's foolish about that picture?
The white man is shooting at the Indian that's far away when the two Indians that are close are about to clobber him.
Mm-hmm.
Group testing became the norm.
Please print your name on the line at the left side of the answer sheet. Then fill in.
Testers often overlooked the fact that such tests could be biased because people did not share the same culture, language, or experience.
Ready? Begin.
In the 1960s, such practices came to be questioned.
We found in our study of the children in the public school population that there were about 300% more Mexican-American children and about 200% more black children than you would expect in classes for the mentally retarded. That became a key issue subsequently in the court cases because the issue then became, are there really disproportionate numbers of black and Hispanic children who are mentally retarded? And the conclusion was that no, that was probably not the case. The difficulty was that the test, which was an English language test, was testing them over cultural materials that they had had limited opportunity to learn. And their performance was being compared with middle-class white children who had had a great deal of exposure to the English language.
We have to understand in testing intelligence that we are not really able to test intelligence per se, because Intelligence itself is a hypothetical idea which we have defined as being reflected by certain kinds of behaviors. What the intelligence test does is elicit behaviors from subjects which we believe reflect their different kinds of intelligence.
Good. I'm going to show you some pictures and ask you to look at each one and identify for me what's missing. Okay? And we'll start with that one. Tell me what's missing from that picture.
The hair.
So the purpose of the test is to illustrate for us behaviors which tell us different things about how the person thinks, learns, and remembers, the different functions of intelligence.
Historically, psychologists have differentiated between what they called IQ tests, intelligence tests, and achievement tests. IQ tests presumably measured the child's potential, their intelligence, while the achievement tests measured what they had learned in school.
Some people do say that intelligence tests are measuring achievement. The reason for that is probably that IQ, as such, correlates with scholastic grades so closely. In point of fact, intelligence tests and achievement tests measure different things. They are related, but they're different things. Intelligence is intended to measure ability, whereas achievement tests measure the quantity of material that's been mastered or learned.
Now, this particular belief, this myth, if you will, that you can measure intelligence separate from achievement, I believe is the primary fallacy in the IQ paradigm, in the use of IQ tests. The fact of the matter is that both of these tests measure what a person has learned.
The difference between achievement tests and IQ or intelligence tests is one really of a continuum rather than a discrete or concrete difference. But any IQ test is going to require some degree of achievement in order for a person to perform on it.
The trend for assessing intelligence is towards an ecological approach. And by that I mean rather than focusing on the child's problem or what we have to change in the child, we're trying to look at making changes in the child's environment. For instance, the class setting, the home structure, taking a total look at where the child is living, what he's doing, and how we can make changes in that particular area.
The concept of intelligence that we deal is in school as the ability to learn. There is a need to assess this. Students get referred for assessment generally because they are not able to learn. In one area or in all areas, the teacher will notice that the youngster generally says doesn't finish work, makes too many mistakes, isn't catching on. One of the most important problems that we see here, or one of the most prevalent, is the youngster who doesn't learn to read.
Not I said the duck, not I said the cat, not I said the pig, not I said the...
You already said that.
Then I'll do it myself, said the little red hen.
In first grade, this may not be yet quite so obvious because there are fewer words on a page. A youngster who is alert and interested may memorize it. But by second grade, the youngster who hasn't learned the system will not be able to do the work, and the teacher will typically refer them.
Can you come up and show me what to do? Want to come up here and write talk to us?
Educators are experimenting with ways to meet the specific developmental needs of children. This problem can be especially challenging when dealing with children of ordinary intelligence who are achieving below grade level.
After we put it together, the little train can run on the table.
I think one of the most important areas of improvement that I see and that is very important for these students is a building of self-esteem. And when they're in the regular class, having some learning difficulties, they tend to get lost and they don't feel real good about themselves. They don't have a whole lot of room for achievement because the teacher with 30 or 40 students in her class doesn't have time to promote achievement, and help those students as much as they can. So I think one of the major areas is building of self-esteem.
I want to my dad.
Special education is used only when all the other interventions have not succeeded, especially at the elementary school level. We try, of course, especially in the earlier grades, just to help the child in the classroom, and maybe with a little tutoring on the side. If a child really does need total assessment, and if they do qualify for special education, then we try to put them in what they call the least restrictive environment. There is some labeling involved in being in a special class. As much as you would like to think there isn't, children at a very young age realize when one particular child is leaving the classroom to go to a special teacher that there is some kind of problem.
Okay, now Felipe, let's start with your ones. Can you take 8 ones away from 2 ones?
No.
You can't? No, you can't. That's right. So what do you need to do, Felipe? You need to borrow 1 10 from the 3. Very good. Take 9 away from 18. Can you do that?
Fortunately, we have a lot of teachers who are kind enough to work that problem out within the classroom and to explain to the children that the child does need special help, but in other words, they're very much like everybody else in the class. And in those situations, we have a very good response for the child, and the child doesn't suffer.
Excellent. Good job. I know, whose turn is it? Charlie.
Middle childhood is a time when the child's thinking and reasoning comes closer to that of an adult. The child has come far, yet the journey toward a truly mature mind still lies ahead. While some researchers have provided useful descriptions of these changes, no one theory adequately explains the wondrous and multifaceted growth of the child's mind. We see that even though there may be a pattern to this development, every child's intellectual abilities are unique, and the real differences may lie in how we help each child to make the most of what they have.